October 1944, somewhere in occupied France. Feldwebel Kurt Adler and his maintenance crew were picking through the wreckage of an American P-51 Mustang when they found something that shouldn't have been there. A metal box, roughly the size of a car battery, mounted behind the pilot's seat. It was heavy, precisely machined, and warm to the touch, even though the aircraft had been down for hours. Adler had examined dozens of crashed Allied aircraft, stripped them for intelligence, salvaged parts when possible. But he'd never seen anything like this. "Get this to the truck," he ordered. "Be careful with it." The box had no obvious external damage despite the violent crash. Whatever was inside had been built to survive. That alone told Adler this was important. The Americans didn't armor non-essential equipment. 2 days later, the box sat on a workbench at a Luftwaffe technical facility outside Paris. 3 engineers stood around it, tools ready, notebooks open. Hauptmann Friedrich Weber, who'd spent the last year analyzing captured American technology, examined the mounting brackets, the electrical connections, the cooling vents machined into the housing. This wasn't auxiliary equipment. This was integrated into the aircraft's core systems. "Before we open this," Weber said, "I want theories." "What are we looking at?" The guesses ranged from a new radio system to some kind of weapons controller to an upgraded oxygen system. None of them were close. Weber carefully removed the housing bolts. The top panel lifted away, revealing what was inside. For several seconds, nobody spoke. They were looking at something that would fundamentally change their understanding of why American fighters were dominating the skies over Europe. Something so advanced, so precisely engineered, that it seemed impossible it could exist in 1944. And something that explained why German pilots, with superior flying skills, were being shot down by American pilots who should have missed. Inside that box was a device called the K-14 Gyroscopic Gunsight. And what it did was turn average pilots into marksmen and good pilots into something close to unstoppable. Weber's hands moved carefully over the mechanism. Gyroscopes, smaller than anything he'd seen in German equipment. Mirrors angled precisely to project a reticle onto the pilot's windscreen. Gearing mechanisms that looked like they belonged in a Swiss watch factory, not a combat aircraft. Electrical connections running to sensors that detected airspeed, altitude, and G-forces. This wasn't just a gunsight. This was a mechanical computer that calculated where bullets would go before the pilot pressed the trigger. "This is solving deflection," Weber said quietly. "Automatically." The other engineers looked at him. Deflection shooting, hitting a moving target from a moving platform, was the hardest skill for fighter pilots to master. A pilot flying at 400 miles per hour trying to hit another aircraft, also flying at 400 miles per hour, had to aim not where the target was, but where it would be when the bullets arrived. The calculation involved relative speeds, angles, range, bullet trajectory, even the ballistic properties of the ammunition. German pilots learned this through hundreds of hours of training and combat experience. The best ones developed an instinct for it. Most never truly mastered it. And now Weber was looking at a device that did the calculation automatically, in real time, continuously adjusting as conditions changed. The pilot just had to get the moving reticle on the target and fire. The gunsight handled everything else. One of the engineers, a former pilot himself, understood immediately what this meant. If this works as designed, it eliminates the skill gap. A pilot with 50 hours can shoot like a pilot with 500 hours. If it works, Weber repeated. Let's find out. The testing began the next morning. They couldn't install it in a German fighter. The electrical systems were incompatible, but they could bench test it, power it with external supplies, simulate flight conditions, and verify the calculations. Weber's team spent 3 days with the K-14, documenting every component, measuring every dimension, testing every function. The gyroscope spun at precise speeds, providing stable reference even when the simulated aircraft banked and turned. The computing mechanism, all mechanical, no electronics, calculated lead angles with remarkable accuracy. The projected reticle adjusted size automatically to indicate range, giving the pilot instant feedback on whether he was too far, too close, or at optimal firing distance. But what truly shocked Weber's team was the manufacturing quality. Every component was machined to tolerances that seemed unnecessary for military equipment. The gyroscopes were balanced so precisely they could spin for minutes without power. The gearing had zero backlash, meaning movements translated instantly without mechanical play. The mirrors were optically perfect, the coatings flawless. This device had been built to automotive industry standards, maybe better, and the serial number stamped on the housing suggested this particular unit was one of thousands, not a prototype, not a limited production run, but standard equipment being installed in American fighters as they rolled off assembly lines. They're mass-producing this, Weber wrote in his initial report. Manufacturing complexity suggests significant industrial investment. This is not experimental technology. This is operational equipment deployed at scale. The implications were staggering. The Luftwaffe had been losing experienced pilots steadily since 1943. The replacements, young men with minimal training because Germany no longer had fuel or time for extensive flight instruction, were being shot down rapidly by American pilots who seemed impossibly accurate. Weber had assumed the Americans simply had better training, more flight hours, superior tactics. Now he understood. They had a technological advantage that compensated for skill gaps. A German pilot needed hundreds of combat missions to develop deflection shooting instinct. An American pilot got that capability the day he strapped into a P-51 equipped with the K-14. Weber's team tried to reverse engineer the Gunsight to understand if Germany could produce something similar. The answer came back quickly. Number, not at the precision required, not with materials that were increasingly scarce, not with manufacturing capacity being bombed regularly, and definitely not at the scale necessary to equip the remaining Luftwaffe fighters. The K-14 required miniature gyroscopes that German industry couldn't produce in quantity. It needed precision gearing that exceeded German manufacturing standards. It demanded optical components that only a handful of facilities could make. Even if Germany started production immediately, it would take years to achieve what the Americans were doing now, installing these sites in fighters faster than Germany could shoot them down. One engineer did the mathematics on combat effectiveness. Against a maneuvering target at typical combat ranges, an average pilot using traditional fixed gun sights might land 5% of fired rounds. The K-14, according to their testing, could theoretically improve that to 15 or 20%. In practical terms, that meant American pilots needed 1/3 the ammunition to achieve the same number of kills. Or conversely, with the same ammunition load, they were 3 times as deadly. This explains the loss rates, Weber wrote. Our pilots report American fighters opening fire at what seem like impossible angles and achieving hits. We attributed this to luck or overwhelming numbers. Now we understand they have a computational advantage that allows successful deflection shooting from positions we would consider non-viable. The testing revealed another advantage. The K-14's automatic ranging reticle meant American pilots knew instantly when they were in effective firing range. German pilots had to estimate range based on experience and visual cues. This often resulted in firing too early, wasting ammunition on shots that couldn't connect, or holding fire too long and losing attack opportunities. The K-14 eliminated this guesswork. When the reticle reached optimal size, the pilot fired. Simple, efficient, deadly. Weber's team examined the installation hardware, the mounting brackets that connected the K-14 to the P-51's airframe. The design was elegant, allowing the sight to be installed or removed in under an hour. This meant maintenance was simple, replacement was fast, and damaged units could be swapped without grounding the aircraft for extended periods. German equipment, built to higher manufacturing precision, but without consideration for field maintenance, often required specialized tools and significant time for installation or removal. The American approach prioritized operational availability over engineering elegance. The power requirements told another story. The K-14 drew minimal electrical power, well within the capacity of the P-51's generator. German attempts at gyroscopic sights had foundered partly on power consumption issues. The Americans had solved this through efficient design and better electrical components. Every aspect of the K-14 reflected a mature industrial base that could produce complex equipment reliably at scale. A captured American pilot, shot down near the same location where the P-51 wreckage was found, was brought in for questioning. Weber asked about the Gunsight, carefully trying to determine how much training pilots received on the system. The American, a lieutenant with fewer than 100 combat hours, was surprisingly open. They gave us maybe 4 hours of classroom instruction and some practice on the ground trainer. After that, you just use it. It's pretty intuitive. You put the pipper on the bandit, adjust your lead until the sight settles, and squeeze the trigger. Way easier than the old fixed sight we trained on. 4 hours of instruction. Weber had spent years mastering deflection shooting as a pilot before the war. This American lieutenant, with minimal experience, was using a device that did automatically what had taken Weber hundreds of flight hours to learn. The frustration was profound. Germany had excellent pilots, brilliant tacticians, innovative aircraft designs, but they were losing the equipment war to American industrial capacity and American willingness to let machines do what had traditionally required human skill. The report Weber submitted to Luftwaffe High Command was comprehensive and bleak. The K-14 gyroscopic gunsight represented a significant American technological advantage that Germany could not counter in the time frame that mattered. Manufacturing the device at scale was beyond German capability. Even if production began immediately, American bombing of German industry would likely prevent successful mass production. The recommendation was stark. Luftwaffe pilots needed to avoid engagement conditions where American pilots could utilize the K-14's advantages, meaning defensive combat, beam attacks, deflection shots at maneuvering targets. But avoiding those conditions meant avoiding combat itself. The Luftwaffe's mission was defending German airspace against American bombers. That required aggressive interception, close-range combat, exactly the conditions where this K-14 gave American escort fighters devastating advantages. Weber knew his recommendations were essentially impossible to implement. German pilots had to fight. They had no choice. And they were fighting an enemy with a technological edge that turned competent pilots into aces. By late 1944, American P-51 Mustangs equipped with K-14 sights were achieving kill ratios that seemed impossible. 8-1, 10-1. Individual pilots were running up scores that eclipsed German aces with years of combat experience. The Luftwaffe attributed this to overwhelming numbers, to American production capacity that replaced losses faster than Germany could inflict them. That was true, but it wasn't the complete story. The K-14 was force multiplying individual pilot effectiveness to levels that traditional training could never achieve. German pilots who survived encounters with P-51s reported the same experience. American fighters attacking from angles that should have been ineffective. Tracer rounds connecting from positions where deflection seemed impossible. Kills achieved with brief firing bursts that suggested remarkable accuracy. The Germans assumed they were facing elite pilots, Americans with hundreds of combat hours and natural shooting ability. Often they were facing pilots with minimal experience who were letting the K-14 do what they hadn't yet learned. The K-14 wasn't perfect. It required the pilot to maintain steady flight during the firing pass, meaning evasive maneuvers disrupted the calculation. It needed accurate airspeed and altitude data, which meant the aircraft's instruments had to be functioning correctly. Combat damage to the gyroscopes could render the sight useless. But even with these limitations, it represented a quantum leap in fighter effectiveness. A pilot who understood the sight's capabilities and flew to maximize them became far more dangerous than the same pilot with traditional equipment. Weber's final assessment, written in December 1944, as American and British forces closed in from the west and Soviet forces advanced from the east, was brutally honest. American technological advantages in fire control represent systematic industrial development we cannot match. They have fielded operational equipment that automates skills requiring years of pilot development. Our response capacity is insufficient. Production impossibility combines with strategic material shortages to prevent effective countermeasures. The K-14 gyroscopic gunsight exemplifies American manufacturing philosophy. Adequate technology deployed in overwhelming quantity with standardized production, allowing rapid equipment fielding. Germany's approach, pursuing engineering perfection in limited quantity, cannot compete against this industrial model. The captured K-14 was eventually shipped to Germany for further analysis. It disappeared in the final months of the war, likely destroyed in bombing raids or lost in the chaos of Germany's collapse. But the intelligence it provided, the understanding of American capabilities it revealed, came too late to matter. By the time Weber's team had fully analyzed the device, understood its implications, and documented Germany's inability to produce equivalent equipment, the Luftwaffe was already broken. Fuel shortages grounded much of the remaining fighter force. Experienced pilots were dead or captured. replacements were flying missions with barely enough training to take off and land. No amount of technical intelligence could reverse the inevitable outcome. American pilots continued using the K-14 through the war's end. The sight proved itself in combat from Western Europe to the Pacific Theater, equipping not just Mustangs, but also P-47 Thunderbolts and later models of other fighters. Pilots who'd flown both with and without the K-14 universally preferred the gyroscopic sight. It made them better shooters, more confident in combat, more likely to survive. The device that German engineers had studied with professional admiration and strategic despair became standard equipment on American fighters. Just another example of American industrial capacity, translating technological innovation into operational advantage at scale. The mechanics who'd pulled that metal box from the crashed P-51 in October 1944 had no idea what they'd found. It looked like just another piece of equipment, another intelligence prize to be documented and analyzed. But inside that precisely machined housing was proof of why Germany was losing the air war. Not because American pilots were inherently better, though many were excellent. Not because American aircraft were overwhelmingly superior, though planes like the P-51 were remarkable. But because American industry could take a complex mechanical computer, miniaturize it, perfect it, and install it in thousands of fighters faster than Germany could train pilots to manually do what the K-14 did automatically. That was the lesson of the gyroscopic Gunsight. Individual German pilots might be more experienced, more skilled, more aggressive. But American pilots had better tools, produced by an industrial base Germany couldn't match, deployed in numbers Germany couldn't counter, supported by a logistics system that kept them flying while German fighters sat grounded for lack of fuel. Technology, production, logistics. The American formula for air superiority. And a small metal box pulled from a crashed fighter in France was proof that the formula worked.